All right, here's part 4 of our lecture on pointers. We're going to create a 2D array, so a dynamically allocated 2D array. But first we're going to go back and revisit how we create a 2D array, right, that is statically created, meaning its size is known at runtime. So here's an example program with main, right? I've got a constant here inside main, a local constant called rows, set that equal to 3. Here's a global constant for columns, set that equal to 2. And so here in main then, I'm creating an array of integers. So a 2D array, I'm declaring this. All right, remember 2D arrays are in row, column order, right? So I'm going to specify the number of rows and the number of columns. So we're going to have 3 rows, 2 columns. And then I'm going to call a function to fill the array. And this is to remind you of that notation. So when we use a 2D array as a parameter in a function, remember, we have a data type, we have a name, doesn't have to be named array, I just named it that. We have the empty bracket notation here for the rows, and then for the columns, we have to specify the column size, right? And this is what is not helpful with this form in terms of this function would only ever work for something that was the size cols, right? That had, in this case, 2 columns. It could have as many rows as we want, but only 2 columns, right? We want to move away from that. We want to be able to use variables at runtime to specify the exact size that we need. But you can see in this example, this right uses a nested for loop to go through and fill the rows and columns with random values, right? If we were to actually then, so I'm going to do a run to cursor right here before fill array. Right, so I can bring up the debugger. So locally here in main, we can see array. Now look, array has an address associated with it, and then inside this initializer list, here's another address. So this address here for array is technically, it's a pointer to a pointer. So a 2D array, we're going to find out is a pointer to a pointer. But this address points to the very first element in memory, right? The very first set of bytes that we have reserved for this array. Remember, it's in row major order, so this next address here is the address of row 0. And then inside row 0, so if I open this up, so this refers to row 0. See how you can see this address is the same as this address? So we're going to find out that when we refer to a row, we have a pointer to an int, right? And within that row, so it's data type, see how the int bracket 2, right? This is an integer array. This is a 2D array. So if you think of these 2 brackets here, well, we're going to replace those with pointers, pointer to pointer. A 1 bracket is an int star. So this will be an int star star. This will be an int star. We'll see that in a second. We have 2 columns. Similarly, right, this particular row has an address. This is the start of this row's address, and it's going to have 2 elements in it. So we can think of this as a 1D array. And then row 2, it has its own address for the start of the row, and you can think of that as a 1D array. So basically, if you think about it, this 3 by 2 array, we've got 3 1D arrays, right, that all have 2 columns, right? And so if I were to just go ahead and hit F10, right, to fill this, so F10 just simply executed this function. Right, we can see when this gets done, row 0. Here's row 0, column 0. You can see the values that were stored in here. Right, I've included the C standard library for RAND. I'm not seeding the random number generator, simply so I get the same values every time as I work with this now. Right, row 1, column 0, column 1. You can see these are the values here. Row 2, column 0, column 1. Here are the values here. And so that's how we know how to work with an array, right? A 2D array. But now that we can dynamically allocate memory, right, we are going to do this much differently. Right. So here, let's create 2 lowercase variables, rows, column. Let's set them equal to the same thing, rows, cols, right? 3 and 2. And now let's dynamically allocate a 2D All right. All right. So it's going to be an array of integers, and its type is going to be an int star star. I'm just going to call it ARR instead of our other one, which I called array. All right. I'm going to call new. All right. In this case, right, new int star rows. All right. I'm going to say that first we allocate an array of pointers to the rows, right? So that is our first allocation, right? So in star, right, with a bracket notation, we now have an array of pointers, or an array of in stars, right? A 2D array. So what we're going to find, right? 1D array is an int star, 2D array is an int star star, 3D array int star 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 3. So the number of stars or asterisk here relate to the dimensions of our array, right? And typically you'll hear people refer to this as a star star as a pointer to a pointer, right? It gets a little confusing, right? But this is the form for allocating rows. Now we have to allocate memory for the columns. I'm letting this throw an exception to terminate, right? So remember, if we don't use standard no throw and it can't allocate memory, C++ will just terminate our program without any, without telling us why, right? It will throw an exception. I'll come back to standard no throw after this, but for now, let's just get this idea down, right? So we've allocated our rows. The next thing we need to do is, next, we allocate memory for the columns, right? So for each row, we have to allocate memory for the columns. And we can do that with a simple loop. We can say for int I equals 0, I less than rows. So we want to go through each row, right? We want to allocate, right, memory for the columns. We'll do that with the name of our array is ARR, so ARR at index I refers to the row. That's going to be equal to, we're going to call the new operator. Our data type is int. And how many ints do we want? Well, we want number of columns. Right. This goes through then and allocates memory, right? So when this finishes running, we have memory for our 2D array, our dynamically allocated 2D array. And so what if I name this one static array, right? That's what we're doing. So static meaning at runtime, we knew the size. And let's create then one that's void fill dynamic array. Right. So this is an int star star. I'm just going to call it A. We need to tell it how many rows we have, how many columns. And that nested loop we're using down here, it's going to work just fine. Except now I purposely just called this A to call it something different. I could have called it array. But once again, just like we could with 1D arrays, we can use the bracket notation. Right? So we run through this in the same way, right? We're going to go for each row across the columns. We're going to fill this with a random value. Right? So instead of calling fill static array, I'm going to call fill dynamic array. We give it the name of the array, which is ARR, number of rows. number of columns to match the parameters. Right, so name of the array, right? Up here, it expects a pointer to a pointer. That's what a 2D array is. That's what we declare down here, ARR. Its type is int star star. All right. So let me do a run to cursor, and let's hope it builds. And it failed. Why did it fail? Oh, forgot the assignment operator. Anything else? It's complaining that arrays unreferenced, my static one, that's okay. All right, so run to cursor. All right, you can see here, right, ARR, got allocated memory. Inside there, right, we have an int star. It's going to refer to the first row. And so now if we walk through this, so F10, so F11 lets me step into the function, right? So now here in the function, we have A, right? A refers to the start of the 2D array. If we walk through here, F10, I'm just going to walk through A at RC. So there's our first element, got 51. If I actually go to the watch window, and if I say A, at 0, 0, row 0, column 0. Actually, what happens if I say A plus 0, comma 3, that's going to give me my rows. Yeah, let's do that. All right. The first gave me just the first array element, but the name of the array, offset of 0 says, right, you can see the pointer to this is an int star. It points to three rows. And within here then, right, this is row 0. It's going to show us what our first element is in each row. It's not going to show us the second element unless I find a way to write the notation differently. All right, not going to worry about that right now. We're going to continue to step through this. All right, we can see, we can see R and C changing. We go back here. All right. All right, when this is done and we're back here, well, this isn't going to know what this is anymore. But back in main, this should know what ARR plus 0, comma 3 is. All right. All right, and so it's going to show us the first column, right? I would have to literally type ARR 0, 1 if I want to see what's in row 0, column 1, ARR row 1, column 1. All right, see the other. All right, moral of the story, dynamically allocated 2D array, right? Star, star, pointer to pointer, 2 stars, 2D array. Here's the name of our pointer. First thing we need to do is allocate an array of pointers. So the rows, right, are the arrays of pointers. So we're going to allocate the rows. That type is int star. Next thing we need to do is we need to allocate memory for the columns. So for each row, right, new int columns, right? And I did not free that. The other thing we need to do if I stop the debugger is we need to delete that. But we just don't say delete with a bracket. We now need to go through all of the rows. And so let's delete the column memory. So we're going to say for int I equals 0, I less than rows, plus I. And now let's delete ARR, that's the name of my array, at index I. We're going to delete the columns for those particular rows. And then when that's done, delete the row memory. And that's just simply delete empty brackets, name of our array. It has to be done in this order, right? And so that's how we then, right? So if you think about it, we're reversing the order. First thing we did up here is we allocated the row memory, and then we allocated the column memory. When we need to delete, we need to walk through the rows. We need to delete then the memory we allocated for the columns for each row. When that's done, we delete that pointer to the rows, that memory, right? And so that's how we would delete. Now, like I said, we weren't using the no throw exception. If we throw the no throw in here, it makes this a little more complex. Let's take a look at how we would do it with no throw, and let's actually write a function that allocates the memory. So it's going to return an int star star. I'm going to say create 2D array. I'm going to tell it how many rows I want and how many columns I want. All right, similarly, right, I need the int star star. I'm going to call it AR. I guess I'll call it ARR. I'm going to say new, right, standard no throw. And that's an int star, so an array, int star, an array of pointers, right? So the rows. All right, so we allocate memory for the rows, and array of int star pointers. Right. And so now I want to check, right, to see if this is equal to the null pointer. So if this failed, ARR should be set equal to the null pointer. I should be able to say if ARR equal null pointer, then let's display an error message. I don't have IOStream in here, so let me add in IOStream. And I'm going to use the error stream for that, CError, right? And I'll just say error memory allocation. Now, and here's something I've probably not showed you before. We could actually say what function. So there's a preprocessor directive that's built in, double underscore func, double underscore. So double underscore func, double underscore would print out the name of the function. And we could print out the line as well. So double underscore line is in all caps for that preprocessor directive that's already defined, standard NL, right? And so if our program then, in this case, were to have an error allocating memory, we could specify name of the function, the line number, right? When your programs get longer and there's a lot of error messages, sometimes it's really handy to know exactly where the error occurred to have that print out. C++ also has a stream called clog that we've not used yet. Instituting logging can also give you some of that same information. The way I'm doing it here right now, sort of the old school way that we did it before clog came along. All right. And now let's talk about what we want to return. If we couldn't allocate memory, let's go ahead and return the null pointer, right, back to the calling function. If we return null pointer, the calling function should check to see if this is equal to null pointer. We know that we haven't been able to allocate memory. Otherwise, if this succeeded, let's allocate memory for the columns, right? So we're going to, for each row, allocate memory for columns, right? So for int I equals, or we could say R I equals 0, I less than rows, plus plus I. And now I'll just say, all right, ready. So we're going to refer to the row. So ARR at index I refers to the row pointer. And I'm going to say new, standard no throw. Right. And now it's just an integer array, columns. So there's a column memory. All right. I guess this kind of complicates it with the no throw method. So now I'm just going to check and say if ARR at index I, if that's equal to null pointer, then we know that memory was not allocated. And do the same sort of thing here. Memory allocation, function, line number. So here I could say maybe column memory allocation. Maybe here I'd say row memory allocation. Makes it easier to look at the message to know what that is. Right. Now, here's the thing. Right, when this is all said and done, we want to return the null pointer because our function was not able to allocate memory. But we did allocate some memory, right? We know at this point we've already allocated the row memory. So we know that in order to get rid of row memory, we use delete, empty bracket, and the name of the array. That gets rid of the row. But what happened if we allocated some columns? Right? What if we were going through here and we were able to allocate columns for some of the rows? I would indicate how many, right? Let's say we were able to allocate memory for column or for row 0. If that were the case, when this failed, I would be equal to 1. What I'm going to do is I'm going to create a variable called count, set it equal to 0, and I'm going to say while count is less than I. Let's delete that row. We know that was allocated. So ARR at count. Yeah, that's the name of the row. Sorry, I doubted myself for a second, which I do make mistakes. I'll increment count. All right. And so this is going to say, right, delete any column memory successfully allocated for rows. Right. All right, if nothing was allocated, then this won't be true, right? For none of the rows, this will be skipped. But just in case something was allocated, we don't want to leak it, right? So this is where we have to become very memory aware. We're not leaking memory. We have to take care of all of our cleanup, freeing memory, right? Which is sometimes referred to as garbage collection, right? But in this case, we want to free memory. And then we free the row memory, then we return null pointer, right? So only when this fails. Otherwise, we'll be going through here. When this loop finishes, we will have allocated all of our memory, right? And we can just simply return then ARR. ARR is our pointer, right? Name of that, right? Remember that memory will exist after this program. Sorry, after this function finishes, the memory still exists. So we should be able to just return ARR. Right, so that means back here, instead of doing this, memory for the columns, right, memory for this, we wrote a function to do this for us. So I'm leaving in the old. And now we can just call, so int ARR ARR equals create 2D array. We passed that rows, columns, right? We just wrote a function to do this. What we need to do though, right, is we need to check if AR equals null pointer, right? That tells us something wasn't successfully allocated. Actually, we will just go ahead and return 1. Our program will end. I could print out another error message, but since the function was taking care of error messages, right, I'm not going to do that here. I'm just going to say this return null pointer wasn't able to allocate memory. I'm going to return. Filling the static array and all should still work. We still also need to delete the memory. We could write a function to take care of that for us. I'll leave that as an exercise for you if you want to write a function that moves this over to a function and deletes the memory. All right. Let me just make sure this builds. And no. Semicolon. I don't know why I lost my semicolons. All right, that builds. All right, let's come back here. Let's do a run to cursor. All right. Columns, rows, ARR. All right. So this did allocate our memory and fill this. All right. Like I said, here's a function then that allocates. I called it create 2D array. It allocated the memory, returned that. All right. This was a bit more complex, right? We just always seem to up it a notch in complexity in here. But if we're using the no throw argument, this ensures then that we are handling and being aware of whether or not this memory was successfully allocated. All right, that's the end of part 4, right? Dynamic memory allocation for 2D arrays, which I'm sure will be showing up in the homework along with 1D arrays. Right, practice this. This belongs in your note sheets.